Hey kids, Flexing Teacher Weber here with the second video on square numbers. I wanted to show you where some of these square numbers might pop up and where you might have seen them before. So, for example, back in grade 6 and even earlier grades, you were listing factors of numbers. Factors are numbers that multiply to give a certain number. So I just want to show you what some of these things might mean here. So this question says, list the factors of 11, 36, 24 to determine if they are perfect squares. Well, basically, if you paid attention to the first lesson, you'll know which one of these numbers is a perfect square, but I just want to show you how factors relate to this. So if I looked at the factors of 11, 11's a prime number, right? So the only numbers that multiply to 11 are 1 times 11. Now, if you're thinking about actual tactile things, that means that the only object you can form with those factors is a rectangle that has a short side of 1 and a long side of 11. So that means 11 cannot be a perfect square because it doesn't form a square, right? It forms a rectangle. Now, the next number I have here is 36. Now, if you think about the factors of 36, there's 1 times 36, there's 2 times 18, and I'm not going to draw all of these, but what this means is that you can make a rectangle that is 1 by 36, you can make a rectangle that is 2 by 18. Another set of factors for 36 are 3 times 12, and 4 times 9, and 6 times 6. And I think that's all of them. Now, what's important to remember here is that this 6 by 6 is important, right? All of these things would make rectangles. 3 by 12, 2 by 18, 4 by 9. But 6 by 6 is the set of factors that's going to make a square. And that's how we know that 36 then is a perfect square. It has side lengths of 6 by 6 and an area of 36, and so 36 can be called a square number or a perfect square. Okay? The last one I have here is 24. And some of the factors of 24 are 1 times 24, so that would make a very narrow rectangle. 2 times 12, slightly less narrow rectangle. 3 times 8, even less narrow rectangle, and 4 by 6. This one is pretty, I'll just erase that. I want to erase that, there we go. This one right here, the 4 by 6, is pretty close to a square, but it's not quite a square. None of those pairs of factors will make a square, so 24 is not a square number. So that's how factors relate to square numbers and perfect squares. Same thing here with some bigger numbers. I've actually given you the factors. Use the factors to determine which are square numbers. Okay, so the number 225, I've put all the factors of 225 on here. We have 1 times 225, 3 times 75, 5 times 45, 8 times 25, and 15 times 15. Since 15 times 15 makes a square, that means 225 is a perfect square. Same thing with 500. Let's look at 500. 1 times 500, 2 times 250, 4 times 125, 5 times 100, 10 times 50, 20 times 25. There's not one number that you can multiply by itself to get 500, so 500 is not a perfect square. Now 324, you've got 1 times 324, 2 times 162, 3 times 108, 4 times 81, 6 times 54, 9 times 36, 12 times 27, and 18 times 18. And since there's that one where you multiply one number by itself to get 324, you can say 324 is a perfect square. And the last one here, 160, the numbers that multiply to 160 are 1 times 160, 2 times 80, 4 times 40, 5 times 32, 8 times 20, and 10 times 16. There's not one number that you would multiply by itself to get 160, so 160 is not a square number. I just want to go back here to 225. I think I had an error on there when I said 8 times 25 makes 225. That should actually be a 9 there, I think. That's why I hesitated a bit. But it doesn't change the answer. The thing to remember there is that 15 times 15 makes 225 a square number, or a perfect square. Okay, so after all of this, the main thing that you have to do, or the thing I'm going to get you to do today, is what I have here is a list of the perfect squares from actually 1 to 30. You've talked a lot about these already, right? 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16, and so on. And then that list continues in this row as well. I don't want you to worry about the row that says square root yet. We're going to talk about square roots tomorrow. But what I want you to do, or what I want you to be able to do, is I want you to memorize the perfect squares from 1 to 20. So what that means, you have to know all the perfect squares in this column from 1 squared. Oh, I'm going to take that back there. You have to know all the perfect squares from 1 squared all the way to 20 squared. So all those ones I've just outlined, you have to know all those perfect squares. You have to know everything from 1 squared equals 1 all the way from 20 squared equals 400. And I've put this paper in Shobi as well, so you can print it off or whatever if you want. So that's your assignment today, is to memorize those perfect squares. And we'll pick this up again tomorrow. Flexing Teacher Weber, out.